channel. So today we'll be looking at how we can be able to download or acquire digital elevation model, which is popularly known as DEM, or SRTM, which is shuttle radar topographic mission, which is a class of data which you can be able to use. So all of them falls into the category of our digital elevation model. So how do we acquire this data so that we can be able to use it to do various analysis, which include topographic analysis, drainage basin or hydro analysis, and all that. So first of all, we need to be able to determine the area which you're working on. So this is my ArcGIS. So the area I'm working on is called Nsukka. Is a local government in Enugu State of Nigeria. So you can see the boundary of the local government. So I'm trying to get a digital elevation model for my study, which is basically on Nsukka. So first of all, let me look at the entire state boundary, because when you get to your data source, you might not find the local government boundary. What you might find might be the state boundary. So it will help me to be able to determine the coverage of my study. Okay. So these are the environment which I'm going to study, and I'm going to proceed to my Google Chrome browser, so I can be able to access this the database. So the database we are going to be using is USGS, which stands for United States Geologic Surveys. So that is what we are going to be using. So we are going to be using the URL. So you can be able to get the URL from the screen or from the caption. So we go at explorer. You can see it explorer.usgs.gov, right? So we are going to open it. So we are going to load it. We are going to see our interface for the data. So it's loading. It's loading. This is our interface for the data. There's our interface for the data. So you can use your scroll button on your mouse to be able to zoom in and zoom out, or you can also be able to use the zoom in and zoom out button at your top right of your map. So you can see it, the plus sign and the minus sign. So when I click on the minus sign, I'm going to be zooming out, so until I get my location. So Enugu State is located in Nigeria, which is in Africa. So I'm going to be zooming in into Enugu State. So I can use also my scroll button, or I can use my plus sign, button on my map. So I'm going to zoom in, and from our boundary, which we are looking at, these are boundaries, so we can be able to know the location of Enugu. And also you can see that Enugu also is written boldly on the map. So we are going to zoom into our area to be able to see our location. So now, for us to be able to cover our area, let's look at our map. You can see where our location falls within the map of Enugu State. So we are going to click at various points, make 4 points within this map environment, so that we can be able to see our location. So I'm going to make 1 point here, another point here, another point here, and another point here. So what I'm trying to do basically is to make sure that the elevation model covers everything which I need within my data. That is what I'm trying to do. So I'm going to scroll up to my data set. So I click on my data set, and I can see this elevation model. So I click on it to expand it. So I can scroll down to. So under this digital elevation model, we can see a lot of data from there. We can see CONET, eDNA, and rest of them, even GTOPO 30 meter cell size. Okay, so I normally like to use SRTM, which stands for shuttle radar topographic mission. So I'm going to use SRTM. So under SRTM, I'm going to use void field. So you can see void field and non-void field. Non-void field means they have not filled a lot of, like, if you get your data, you can see a lot of negative sign, or maybe minus 30, minus 15 in your data, which is showing more like the depth, probably around the river area. So I'm going to use void field so that I can get a digital elevation model that is already void field. So I click on it, void field, and I'm going to scroll up again. You can go up here or you can go down. So I'm going to go up here again and click on my result. So the system is going to load my result and show me a list of data. So also bear in mind that for you to be able to download information or data from this database, you need to create an account. It's a free account which you can create, from here. So I'm going to show you. So looking at this now, you can see a lot of buttons, a lot of the digital elevation model here, and a lot of buttons attached to them. So the first button that looks like a foot shows footprint. So when you click on it, the system will show you the area which the digital elevation model is covering, right? And if you click on the second one, you are going to be seeing the digital elevation model the way it is on that particular spot. So also we now have compare browse, where you can compare to. You also have show metadata in case you want to get a metadata of your digital elevation model which you want to download. We now have download here where you can be able to download your digital elevation model. You have add to bulk download, so you can add all of them, lump all of them up, all the things you want to download into a single file and download all of them at once. So you also have exclude scene from result. So I'm going to look for the particular digital elevation model that covers this environment. So I'm going to check here. So here covers more of my study area. So I can go back to my study area to confirm. You can see it covers my study area, because the other part of the area that is cropped out probably does not touch my study area. You can see from the map. But also, to be on the safer side, you can decide to check to get the upper part of the image which is cropped out. So I can decide to check to get the upper. Okay, there's the upper part of the image. So now that I've confirmed the two digital elevation model raster that covers my area, I'm going to click on download here. So I'm going to download this one first. So the file I'm downloading is the GeoTIFF3 arc seconds, which is 2.76 megabytes, right? I'm clicking here, download, and the system is going to load and show me the download option here. So what do? I go to my working folder. I've thought about the working folder in the previous video, how you can be able to create a working folder so that you can properly organize your data. So I go to my working folder, which is located in my GIS folder, and you can see the area which is in soccer land use. That is my working folder. I open it. I'm going to save this file there, and the system is going to download it. You can also choose to save elsewhere, but I always like to organize my file. Then now I'm done with this one, I'm going to close. I'm going to go to the second image, and I'm going to click on download. The system is going to load up the same thing. I click on download, and this time around is going to save at the same spot where I saved the previous one. So I'm going to click on save. Now I'm done downloading my image. So now I'm going to go back to my ArcGIS. So this is my ArcGIS. So I'm going to open up my ArcGIS. So the next thing I'm going to do is to add the images which I downloaded. So I'm going to click on add data from here, or also you can go through file, click on add data, and add data. So I'm going to add the data. Now, what is the next thing I'm going to do? I'm going to go to my folder connection to see from my folder connection, which is the GIS projects, which is where I normally save my file. So I click on GIS folder, or also you can see if you have saved your work project, you can see it at the last folder here. But here, I want to go through the process. So I'm going to look for soccer. You can scroll, or you can use hint words to be able to get this done. So this is soccer LGA land use. I'm going to open it. So inside this, you can see the two images I download. One is N06, the other one is N07. That's the starting word. So I'm going to click on the first one, hold down Control, click on the second one, and then add the two into my map environment. So now I've added the two into my map environment. Let me zoom in and then remove my state boundary, so we can see whether the image is captured in both. So okay, so you can see that some part of the local government is outside, so which means we took the right decision by downloading these two imagery. Now what's the next thing I'm going to do? I'm going to convert these two imagery into a one image, and it's called mosaic, using a tool called mosaicing. So I'm going to mosaic both of the imagery into two single imagery so that we can be able to extract them. So I'm going to click on my arc toolbox, and I'm going to go down to data management. I click on data management. I'm going to go down to raster under my arc toolbox. Then I'm going to go down to raster dataset. I open up the raster dataset, so you can see copy raster, create random raster, and all that. So we are going to using mosaic to new raster. So I'm going to open my mosaic to new raster. So now it's open. I can click on input data here to add the two if I want to, or I can simply go back here, click on my table of contents. The two are still highlighted, but if they are not, you can use Control to highlight the two and then drag the imagery into this place. So now we are going to now set other things which we need to do for us to be able to carry out this analysis. First of all, it's asking for an output location. So we're going to select the output location. Take note that the output location is a folder where it's going to be saved, not the exact file name. So we are going to look for our working folder, which we are going to use to save our file. So I'm going to click on this in Soka LGL land use as the folder, and I click add. So the system is going to add the folder to my output location. So whenever I analyze my file, that is where it's going to be. So it's now asking you for the raster dataset name and extension. So I'm going to call it elevation, or DEM .tif. I like to save my file in TIF. So .tif. Now it's asking you for the other reference. So how do you get the other reference? You're going to come to the file which is in your table of contents, right click it, click on properties, and under properties you can go to source. Here, if it's in general, you can go to source. So from source, you can be able to see your data attributes. So we are seeing that the cell size here is 0.008333 by cell size. That is because the default data is in geographic coordinate system. So when we convert them to projected coordinate system, we can be able to now ascertain the actual cell size by meters. So now go down here, you can see pixel type signed integer 16 bits, right? Number of band 1. So that is what we are going to use. So we are going to come here and say 16-bit signed, and cell size option no. Then we go to band, number of bands, we say 1. That is a single band image. Then there's another thing you can do if you wish not to do the second step, which is masking it. You can be able to use the system to max out your location if you want to. So when you want to do that particular one, you can go to environment, and on environment you click on your processing extent. So click here, which is extent, and select the boundary, which is the LGA boundary, if you want to mask directly. So I will do the two process so you can be able to understand better. So I click on the LGA extent, and I will scroll down again, and I'll go to raster analysis, and it will ask me mask. What am I going to use to mask it so that it will be with the shape of our boundary? I'm going to click on mask, and I'm going to click on LGA boundary, and okay, that is it. So now that I'm done with all the settings, I'm going to click OK. So if I click OK, the system is going to analyze it and give me my raster, mosaic raster. That's our new raster. So now the system are giving us our new raster. This is our new raster. So if I uncheck these ones, you can see a new raster. So the raster is now taking the shape or the extent of our project. So next thing I'm going to do is to go to ArcGIS, and I'm going to go to Spatial Analysis 2 here, open up, then go to Extraction. Click on Extraction. I'm going to click on Extract by Mask. So I'm going to open it. So now it's asking me input your raster, which is our digital elevation model. Then input raster or feature mask. I'm going to mask it with our local government boundary. So that's what I'm going to do. So it's going to ask you for output raster. So I'm going to open the output raster and select our working folder, which is this last folder here, or you can also navigate through here to be able to locate that particular folder. So you can navigate through here to locate your folder, and you can now say DEM underscore mask. So why we put the underscore is because this is a database, it doesn't accept space, so we use underscore to bridge the gap between two words. So I'm clicking on save, and I'm pressing OK. So the system is processing and is done. So you can see that there's a new raster on top of our old raster, which is the digital elevation model. So when we uncheck this, we are going to have the one that contains our digital elevation model. So the next thing you might want to do is to convert this digital elevation model from the geographic coordinate system to a projected coordinate system. So how do I do it? I'm going to click on ArcGIS again. I'm going to go to conversion. So I'm going to go to data management properties, where I mosaiced it to raster, where I did the mosaic analysis. So this is the data management page. So I'm going to go to projection and transformations. So I'm clicking there. So I'm going to click on raster, which is here. So I'm going to click on project raster. So I'm going to click on it, double click on it, and it's going to open the dialog box for me to be able to project my raster, right? So I'm going to add my DEM mask. It's giving me the coordinate system, which is GCS, which is Geographic Coordinate System, WGS, which is World Geodetic System of 1984. So I'm going to select the output location or the name. I'm going to say DEM mask proj, which is projected, right? Do save. So now it's asking me for the output coordinates. The area which we are working on falls within the Universal Transverse Marcator, which is UTM 32 knots. So if you don't have it saved in your system, you can go to projected and then go down to UTM and go down to go back to go down to UTM and then go down to Africa. Sorry. And when you get to Africa, you can decide to use MENA, which is one of our local coordinate system. But if you don't want to use it and you want to get the exact one I'm using, this is what you are going to do. So you are going to go to world, sorry. We are going to go to UTM, sorry, not world. We are going to go to UTM and then scroll down to and the UTM and then scroll down to World Geodetic System, which is WGS 1984, and click open. Then we are looking at 32 knots, which is the northern hemisphere. So we click on the northern hemisphere and we scroll down to look for 32 knots. So we can select it. So here is 32 knots. So I'm clicking on 32 knots and okay. So now I've set my output coordinate system and I'm going to press OK. So the system is going to analyze it and it's going to give me the new file, which is a raster file on a projected coordinate system. So the system is done. If I go back to my table of contents, you can see that this is projected. So if I go to the previous one and I click properties and I look at the source, you will see that the source is GCS WGS 1984 and the cell sizes are 0.0083 exponential. So if I go back here and click on properties, which is the projected one, we are going to see cell size 92.457 like that. And you are going to scroll down here, you will see that what we have here is WGS 1984, which is a projected coordinate system. Linear unit is meters. So, okay. So now I've converted to projected coordinate system. I can now decide to style my digital elevation model by going to the properties. So if I go to properties, I'm going to symbology. So when I get to symbology, I can decide to choose different other colors to represent my digital elevation model. I can choose this and I click on apply and you can see your digital elevation model, or I can also use classified. So when I say classified, I can decide to classify it into 10 classes and I choose the method which are the color palette which I want to use. Probably I want to use this color and I press OK. So you can see the classified, that there's a streamline boundary between the different classes of the digital elevation model, unlike when it comes to stretch where it's just stretched across. So that is it. So you can decide to go further in classification to click on classify, and then you can decide to make it equal interval instead of natural breaks. So when I make it equal interval, it means that the intervals across them becomes equal. Okay, so this is it. So it's now having equal interval. I can also decide to modify the label because I feel that there are like a lot of zeros in the label, which does not really make sense. So I can click on the label and click on format label. So here I can decide to say decimal places. I don't want it to have any decimal places. I want all of them to be whole numbers. So I'm going to reduce it to 0 and press OK. So you can see the interval 129 to 174. Then the other one starts at 175. And I press apply and OK. And it appears on my legend. So this is how to basically download and extract digital elevation model for your project, whether it's hydrological study or terrain study or topographic study. So thank you. See you guys. And don't forget to follow and comment and also share so that other people can benefit from this knowledge. Thank you.